This is Targ Zaki, and it is 7:30 p.m. on February 21st, 2019. This is the third video log of the crystal alum growth. There are still several crystals at the bottom of the vial, and there are crystals growing on the side of the vial as well. The crystals at the bottom of the vial have grown noticeably and are larger. The water level in the vial has also gone down, showing that some of the water has evaporated. The vial has been stored in the same place for the past 5 weeks, so there has not been any change in the environment of the vial or the crystals. The vial we produce has several small crystals at the bottom. However, a single large crystal would have been more ideal. A single crystal could have been made if the solution was exposed to a smaller surface area where fewer crystals can form. Also, it would be better if the KSP of the solution could be reduced so less of the alum would be dissolved in the water. Despacing is a phenomenon that occurs due to the periodicity of crystals. Crystals are composed of a unit cell of atoms that is repeated throughout the entire crystal. This leads to different sets of parallel planes of atoms in the crystals to be formed at different angles. Each set of planes has a uniform spacing between them, known as the d-spacing. Planes with smaller d-spacings are more frequent. The d-spacing is important because it can be exploited to show the arrangement of the atoms in the crystal. When X-rays are shown onto the crystal, they randomly go through some of the planes and reflect off others. When d-spacing is 2 sine theta times the multiple of the wavelength of the X-rays that bounce off of the different plates constructively interfere with each other, which causes the intensity of the reflected X-rays to be higher. When the intensity of the X-ray is graphed along 2 theta, there are clear spikes which show the different planes that are present in the crystal. In our crystal, X-ray, the wavelength was 0.015418 nanometers. 2 theta was 20.5, which made theta 10.25 degrees. The formula for d-spacing is lambda equals 2d sine theta. D equals lambda over 2 sine theta, which simplifies to the d-spacing of 0.043 nanometers.